Hello everyone, this is Dr. E, and for today we're going to be working on angle measurements in our polygons and some construction that will help us understand polygons better. From our previous lessons, we were able to classify our polygons if they are regular or not regular, or convex or concave polygons. And for today, we're going to be working on how to use algebra and properties in geometry to be able to find the measurements of our polygons. But first, let's identify a very important part of our polygon that we can use to measure the interior angles of our polygons. So a segment joining two non-consecutive vertices of a convex polygon is called a diagonal, or diagonals of the polygons. And you are seeing three polygons here with their diagonals. And what's important about these diagonals is that it will help us find the angle measurement or the sum of the angle measurements of these polygons using our diagonal. Notice that in our quadrilateral right here, we're able to produce two triangles by introducing the diagonal of this polygon. And we know that in triangles, one of its theorems, or the interior angle theorem of a triangle, it's always equal to 180 if we add up the interior sides or interior angles of a triangle. And since we're able to see two triangles, that means that the interior angles formed in this quadrilateral is simply going to be two triangles multiplied 280 degrees. So for this quadrilateral or four-sided polygon, to be able to find its interior angles, we simply multiply 2 times 180 degrees, and it's equal to 360 degrees. So a quadrilateral, its interior angle is equal to 360 degrees because from here, introducing a diagonal to our quadrilateral gave us 1 and 2 triangles, which helped us find the interior sum of angle 1, 2, 3, 4 of this quadrilateral. And with this reasoning, we'll be able to also compute for the angle measurement or the sum of the interior angle of this 1, 2, 3, 4, 5-sided polygon or a pentagon. And to be able to do that, we know that all we need to do is to find how many triangles we can have using our diagonals. And now we have 3 triangles. And if we multiply it to 180 degrees, we'll be able to find the sum of the interior angles of this pentagon, which is equal to 540 degrees. And also, since we have the last polygon here with us, which has 1, 2, 3, 4, 5, 6 sides. So this 6-sided polygon is a hexagon. And since we're able to produce 1, 2, 3, 4 triangles, as you can see from our diagonals or the diagonals that's introduced to our polygon, we now can compute for the sum of the interior angles of this polygon by counting the number of triangles, which is 4, multiplied by 180 degrees, which will give us 720 degrees. So now we're able to produce the interior or the sum of the interior angles of our polygons using our diagonals. That's why it's important to know how we can use the theorems that we have previously learned and integrate it and apply it to our lesson today. And that's how geometry works, and that's what we're going to be using today so that we can calculate some of the missing parts or angles of a polygon. Now, let's focus on convex quadrilateral. And convex quadrilateral it has the sum or the measurement of its interior angles is going to be 360 degrees, which is something that we need to remember. So even though you have a regular or no non-regular quadrilateral, if you add their angles, it will equal to 360 degrees. But make sure that your polygon or your quadrilateral is a convex quadrilateral for this theorem to work. So let's try this theorem and measure the sum or even a specific angle in this quadrilateral. So just like in any problem or geometry problem that we previously calculated, solving for x is easier if we're going to draw the figure that we are working on. And in this figure, even though it's ugly, it will still help us because it will help us organize our thought on how we can compute for the value of the measurement of angle C and the measurement of angle D, given that this is x, this is 2x plus 3, and this is 127, and this is 125. And the first thing that we need to do is to produce our equation that will help us in calculating for the value of angle C and angle D, or angle D or angle C. And to be able to do that, we know that the measurement or the sum of the measurement of angle A, B, C, and D is going to equal to 360 degrees because this is a quadrilateral. So all we need to do is to add x degrees, which is the measurement of angle D, measurement of angle C, which is 2x plus 3, and the measurement of angle B, which is 125 degrees, and the measurement of angle A, which is 127 degrees, equal to 360 degrees because this is a quadrilateral. And now that we have our algebraic equation, all we need to do is to combine like terms and find the value of x. So from here, we're able to simplify our equation, and we know that x plus 2x is equal to 3x, and 3 plus 125 plus 127 is equal to 255, equal to 360 degrees, and by too many pluses, by solving for x, minus 255, it will give us 3x is equal to 255. 360 minus 255 is 105. And we divide both sides by 3, and x is equal to 73 degrees. And that is how we calculate for the value of x using geometry and algebra. And now that we're able to produce the value of x, which is equal to 35, all we need to do is to substitute the value of x to our angle D and angle C, which happens to be an algebraic expression. So measurement of D is equal to 35 degrees because x is 35, and the measurement of C would be 2 times 35 plus 3, which gives us 73 degrees. And that is how we use geometry and algebra to calculate for the missing angle of our polygon. And this time around, we're going to be doing a little bit of construction, and for this construction, we will be needing our compass and our straight edge and pencil to create a special quadrilateral, and this is special because this quadrilateral is regular, which means they're equilateral and equiangular. Their sides are congruent and their angles are also congruent. So let's have our special tools right here. And we know that we are constructing a quadrilateral that happens to be, is it 2 L's or 1 L? I think it's 2 L. Quadrilateral. You know what? I'm not too confident with my spelling right now. So I'm going to say we're going to be constructing a four-sided polygon, and it's going to be regular. And why is it regular? Because their angles are congruent and their sides are also congruent. Notice that I use the symbol because I'm also not sure about my spelling for congruent. But this is what we're going to be constructing using our tools. So let's start with our straight line. And our straight line will help us to produce a perpendicular bisector and also a circle. So let's draw a straight line right here, and let's use our compass to produce a circle, and this circle is going to be helping us to draw our regular quadrilateral, knowing that our center is here. We're going to produce a perpendicular bisector. And how do we produce a perpendicular bisector? Just adjust your compass and make sure that the width is slightly bigger than your radius so that you'll be able to produce a point of intersection from the both ends of our diameter. So put your needle on both ends of the diameter and construct a curve right here. And from here, we're able, I can see the first curve, so I'm going to write it over. And it will help us locate the 2 points that will help us construct a perpendicular bisector to our line. And this will help us in constructing our square. How is this figure going to help us find or draw our square? We are now able to create partitions, 4 partitions in our circle, and if we connect those points of intersection from our perpendicular bisector, we can now produce a quadrilateral that is also regular. Why is it regular? Because we know that our quadrilateral is going to have a congruent angles and congruent sides. So how are you going to know that we have a quadrilateral? Let's angle it a little bit so that you would see that we are able to produce a square. And this square, of course, has congruent angles. All of them are 90 degrees, and their side lengths are also the same. And we're able to produce that using our tools, compass, straight edge, and our pencil to be able to find or construct our regular sided polygon, also known as a square. So for your number bender challenge for the day, if you want to challenge yourself, do you think you can create a star like that, a 5-pointed star, using your compass and your straight edge? Comment down below. Let's see if you'll be able to produce that. Or just type it in, the type of polygon, that particular shape that you're seeing. Is it a regular polygon, non-regular polygon? Is it convex or concave? You'll be able to answer this because you already know how we classify polygons such as this. And this is our lesson for today on geometry. We were able to show the importance of diagonals in helping us to calculate for the angle measurements of certain polygons, and also we've learned how to use our compass to produce a 4-sided polygon, also known as a quadrilateral, if you can spell it right, with equal or congruent angles and congruent sides. This is Dr. E, and see you again next time. Bye!